Waste. It's a problem we all struggle with, and there are no simple solutions. Here in Holland, prevention and sorting at the source are already at a very high level. Landfilling has been forbidden for over 10 years now. But here in Amsterdam, they decided there's room for further improvement. They've taken waste management a huge step further and set themselves some pretty remarkable targets. Like many of you, AEB, the Amsterdam Waste and Energy Company, sees waste not so much as a problem to be solved, but more as part of a sustainable production chain. To them, it's not about disposal, but about recovery, about recycling with high efficiency. By using waste as fuel, sustainable electricity and heat are generated as alternative sources of energy. Slag is not simply accepted as a byproduct, but is used as a source for metals, sand and granulate. Emission levels don't simply meet legal requirements, they surpass them, increasingly. A clear vision, but in all honesty, not a unique vision. AEB wanted more because they were not satisfied with just getting energy and products from waste. They wanted to provide the world with better solutions. That's why AEB developed a new, highly innovative waste-fired power plant.
We envisioned that recovery would be a major item in the future, and so the new plant has been designed for recovery as an additional requirement for the classical design to be clean.
Well, interesting starting point was, of course, that we did not put full focus on the waste processing. We really saw waste as a precious resource.
We made it a specific point of design to maximize the production of energy, specifically electricity.
30% of the input we can deliver as output of the plant, and comparing it with a common installation, it's 10% more, and you can see how big our target was at the beginning.
We also made a separate project to improve the recovery of materials from the bottom ash. And what surprised even ourselves was the amount of metals, especially non-ferrous metals, that could be recovered.
30% electrical performance, major recovery of metals, including iron, maximum output. Great prospects, but first a lot of money had to be invested. The city of Amsterdam has full ownership of AEB, so they had to determine the validity of AEB's vision.
The Parliament of Amsterdam was discussing it over and over. It's a lot of money, but in the end we said sustainability is very important.
It's a higher investment, but the income and especially the long-term operational value as an additional value for the city.
The Amsterdam people are better off because they don't pay that much for their garbage. They don't pay that much for their energy. We, as the city of Amsterdam, earn money out of it because we deliver energy all over the region. So I think it's a win-win-win situation.
We have direct contracts with the local government for the supply of all the electricity for public transport, the trams, street lights, and all public buildings.
In the west of Amsterdam we have a system that's called City Heat, and we are going to make that network bigger and bigger. In 10 years, the whole city of Amsterdam will be heated by energy that is very sustainable from this plant. I think as a city councillor, you have the responsibility to take care also for the future of your citizens. So I think it is a subject that has to be high on the agenda of all mayors and deputy mayors of the world.
So, the vision was in place. Getting maximum energy from every ton of waste. Then came the hard part, actually proving it could be done. The AEB technicians reviewed the entire process, searching for every opportunity to realize an extra percentage of electrical performance. They found many small innovations, altogether bringing them closer to the target. The biggest step was made here in the boiler. Carnot's law says that if you succeed in raising steam pressure and temperature, you improve electrical performance. But that's easier said than done. And that's where this installation makes a major difference. They found a better way of converting the energy from the steam in the turbine by means of this so-called reheater.
What we do is we take the steam halfway out of the turbine and have a steam heat exchanger which reheats the steam and then goes back to the last stage of the turbine. And this reheating allows to have higher pressure at the inlet of the turbine. The specific invention we did here was to have the reheating not done directly in the boiler, but indirectly with steam which is taken from the drum of the boiler.
So the pressure could be raised by using the external reheater, but one solution led to the next problem. Higher pressure means higher temperature in the boiler, meaning more fouling, corrosion and maintenance, leading to lower results. Once again, AEB found an apparently simple solution.
You can see here how this material is cladded on the surface of a common pipe, and this cladding, Inconel, will avoid corrosion on the boiler. It's used to repair something, but we use it as a design figure, and this is why we are allowed to increase our temperature and the pressure in the boiler to increase the efficiency.
Along with that, we decrease temperatures of the flue gases and lower the speed of the flue gases. And that altogether lowers the fouling of the boiler, the forming of layers of deposits of fly ash, and it lowers the corrosion.
Getting as much return as possible from your installation also means pushing it to the limit. What you don't want is that all this pushing leads to more stoppages for maintenance or repair. And that's why at AEB they have developed their own approach.
What we did is look at equipment parts in detail and asking us the questions, what could go wrong? Well, and the second question would be, and what would be the consequence if it went wrong? And by eliminating the larger consequences, we have indeed improved the plant. The idea is to exchange larger modules rather than to repair on-site. So exchange the module, repair in workshops elsewhere, and then, well, and this return then is not longer affecting the availability of the plant.
So then you get maximum electrical performance. But in the end, you're still left with the side product, bottom ash. At AEB, it's not considered a problem, but is simply seen as yet another source of useful products. In cooperation with the Technical University of Delft, new techniques were developed to recover the maximum amount of useful content from this bottom ash.
The main of the slag is natural material. It's glass, it's sand, it's stones, and we try to get these fractions back to reuse that, but what we are looking for is this one, and these are the non-ferrous metals, and it's aluminium, it's copper and other non-ferrous metals, but this is what gives the most value on the market and what we are looking for. And therefore, to reuse it, that's the main target for environmental reasons.
So they had a vision here in Amsterdam, using waste as a source for sustainable energy and content, while diminishing emission and side products. And that ambition is in full operation as we speak. And the visionaries of AEB, they already have their focus set on the future.
We think we initiated a different thinking, not only designed to be clean, but designed for recovery.
This plant we designed as a future generation of waste incineration plant, that this plant is really the basic for new plants in the world and other countries, that they look at us and say, okay, we should try the same, and we will copy this plant. And that is our main vision we have. Please take over this high efficient incineration plant.
We are one of the first in Amsterdam, and I hope it will be exported all over the world. When you make energy from waste, I think you make gold out of garbage. That's great.
So, in reaching their self-set targets, AEB solved all conceivable problems. sometimes by inventing new techniques, but often by simply applying existing technology in new ways. The results are a revolutionary plant, and the knowledge that almost anything can be done once you seriously apply your mind.